Title: ThinK. Thin NERKEY cache by query-driven pruning. Abstract. This paper introduces ThinK, a novel query-dependent KV cache pruning method designed to minimize attention weight loss while selectively pruning the least significant channels in large language models, LLMs. The authors address the inefficiencies in KV cache memory consumption during inference, particularly in managing long sequences due to the quadratic complexity of the transformer attention mechanism. Unlike existing approaches that optimize the memory based on the sequence lengths, ThinK uncovers that the channel dimension of the KV cache exhibits significant redundancy, characterized by unbalanced magnitude distribution and low-rank structure in attention weights. Introduction. The paper begins by discussing the challenges associated with large language models, which have revolutionized the field of natural language processing but pose significant computational and memory costs. The authors focus on the long context scenario, where managing long sequences is particularly challenging due to the quadratic complexity of the transformer attention mechanism. Observations. The authors observe that the channel dimension of the KV cache exhibits significant redundancy, characterized by unbalanced magnitude distribution and low-rank structure in attention weights. This redundancy can be leveraged to reduce memory costs without compromising model accuracy. ThinK. The proposed ThinK method is a query-dependent KV cache pruning approach that aims to minimize attention weight loss while selectively pruning the least significant channels. The authors conduct a preliminary study of KV cache optimization and demonstrate the efficacy of their approach through extensive evaluations on the LLaMA3 and Mistral models across various long-sequence datasets. Experiment results. The authors present results on long bench and needle-in-a haystack datasets, showing that ThinK achieves a reduction in memory costs by over 20% compared with vanilla KV cache eviction methods while maintaining or enhancing model accuracy. Ablation studies further confirm the effectiveness of ThinK. Related work. The paper discusses related work in the field, highlighting the novelty and significance of ThinK in reducing both memory and computational overheads for efficient LLM deployment. Endnote and future direction. The authors conclude by outlining the potential of extending their method to value cache pruning, demonstrating ThinK's versatility and broad applicability in optimizing LLMs. They also discuss future directions for further improving the efficiency of LLMs. Title: Efficient Channel Pruning for Large Language Models. Introduction. Large language models, LLMs, have emerged as a dominant paradigm in natural language processing, achieving state-of-the-art performance across various tasks. A key principle, the scaling law, suggests that LLMs exhibit emergent abilities as model size increases, enhancing their capacity to understand context and handle long sequences. This capacity growth allows LLMs to generate coherent and contextually accurate responses and enables various downstream applications, such as document summarization, code generation, and conversational AI. Despite their success in various applications, the generation of LLMs incurs significant expenses, which escalate with increasing model size and sequence length. Consequently, efficient LLMs have gained popularity in recent years. Efficient LLMs. To address these challenges, quantization and pruning methods are employed to reduce model size. Additionally, managing long sequences presents another cost due to the transformer attention mechanism. The quadratic complexity of the attention mechanism results in substantial computational burden when dealing with long sequences, scaling poorly with sequence length. Therefore, effective management of long sequences is essential for the practical deployment of LLMs. In this paper, we focus on the long context scenario and aim to reduce the memory consumption associated with lengthy sequences. Key observations. We identify several key observations that motivate our approach to prune the channel of KV cache. Specifically, we visualize the magnitude of KV cache and perform singular value decomposition of the attention in LLaMA38B model. We show the visualization for certain heads and layers for illustration purposes. Consistent with previous findings, we observe that only certain channels have significant magnitudes in the key cache, whereas the value cache lacks obvious patterns. Given such an observation, it is feasible to prune away certain key cache channels that contribute less to the attention mechanism. ThinK method. We propose a simple yet effective method, ThinK, for KV cache pruning. To pinpoint the least significant channels, we formulate the task as an optimization problem, aiming to minimize the loss in attention weights attributable to pruning. Using this criterion, we then select the most critical channels in a greedy fashion. We evaluate ThinK using the LLaMA3 and Mistral models and validate its effectiveness across various long-sequence datasets. The results indicate that when paired with token eviction methods, ThinK not only achieves comparable or superior accuracy but also reduces KV cache memory costs by more than 20%. Contributions. This work pioneers the investigation into the sparsity structure of the channels in the KV cache. Specifically, we discovered that the activated key cache is sparse given a specific query. This insight allows us to prune the key cache channels using a query-induced norm. Inspired by this phenomenon, we introduce a plug-and-play method ThinK, the first channel pruning method specifically designed for KV cache. ThinK reduces the dimensionality of the cache channel, leading to linear savings in both memory and computational requirements. As plug-and-play techniques, our proposed ThinK is orthogonal to other KV cache compression schemes, e.g., KV cache eviction, quantization. Our extensive experiments demonstrate the remarkable efficiency of ThinK on LLaMA3 and Mistral models. Furthermore, we explore the promising potential of extending ThinK to value cache pruning, ThinKV, in specific scenarios, highlighting the broad applicability of our method. The paper discusses the optimization of key-value (KV) caches in large language models, focusing on the magnitude of key and value caches for LLaMA38B. It is observed that the magnitudes of the key cache channels vary differently, whereas the channels of the value cache do not exhibit such variation. A singular value analysis is conducted to investigate the principal components of the attention matrix, revealing that only a few singular values exhibit high energy levels, suggesting a low-rank approximation can effectively capture the essential information in the key cache. The normalized cumulative energy sum shows that the top 50 singular values account for over 90% of the total energy, further supporting the low-rank nature of the attention matrix. The paper also presents a preliminary study of KV cache optimization, highlighting the challenges in managing large-scale models and the need for efficient memory utilization strategies. Current methods optimize the KV cache based on sequence length and precision, but the authors propose a new method, ThinK, to optimize it from the perspective of the number of head dimensions. A performance comparison of pruning K cache by LP norm on long bench is provided, showing varying results across different methods and benchmarks. The paper discusses the optimization of key-value cache pruning in transformer models, focusing on the redundancy in the channel dimension. It presents two methods for pruning: magnitude-based and query-driven. The magnitude-based method uses the L1 and L2 norms to evaluate channel importance, while the query-driven method aims to minimize the Frobenius norm of the difference between original and pruned attention weights. The authors also introduce a criterion for evaluating channel importance based on the interaction magnitude between query and key vectors. The paper provides experimental results on the long bench benchmark, comparing the proposed methods with baseline methods H2O and SnapKV. A 30% pruning ratio maintains accuracy, but increasing it to 40% results in significant performance degradation, especially for L1 norm-based pruning. The results support the assumption that the key cache is redundant in the channel dimension and indicate the need for a better pruning matrix to achieve higher pruning ratios effectively. The authors also discuss the implementation of their method during decoding, focusing on long context input scenarios. They propose two implementations. One involves zero-filling pruned keys using a mask to restore them to their original size, and the other involves initially pruning the query using the mask. The second implementation has lower computational costs. Finally, the paper presents the results of extensive experiments to evaluate the effectiveness of ThinK on performance and memory reduction. It uses benchmark datasets such as long bench and needle-in a haystack, comparing the proposed method with state-of-the-art KV cache compression methods. The results show that the proposed method can effectively reduce memory usage while maintaining performance in long context scenarios. The paper presents a comprehensive comparison of key cache pruning methods on LLaMA38B and Mistral 7B models using the long bench dataset. The authors evaluate the performance of various key-value (KV) cache compression methods, including heavy hitter Oracle, H2O, and SnapKV, with and without their proposed ThinK channel pruning method. The results show that ThinK can further reduce memory usage and improve performance when integrated with H2O and SnapKV, especially when the pruning ratio is moderate. The authors also compare their query-based channel pruning method with L1 and L2 norm-based pruning, demonstrating the effectiveness of ThinK in improving performance and reducing memory. Additionally, the paper presents results from the needle-in-a-haystack test, which further supports the efficacy of ThinK in enhancing the performance of KV cache compression methods. Overall, the study highlights the potential of ThinK in optimizing the memory usage and performance of large language models. The proposed query-driven channel pruning method, ThinK, is evaluated on various KV cache sizes to demonstrate its effectiveness in retaining informative channels and discarding noisy ones. The results show that ThinK can maintain comparable performance with SnapKV, a state-of-the-art KV cache compression method, even with a larger pruning ratio and smaller KV cache size. The needle-in-a-haystack test accuracy is visualized against different token lengths and depth %, showcasing ThinK's robustness in fine-grained retrieval tasks. Ablation studies are conducted to investigate the impact of different recent sizes on the performance of long bench. The results indicate that a recent size of 32 yields superior performance compared to 0, demonstrating the importance of keeping the most recent KVs. However, increasing the recent size to 128 does not significantly improve performance, suggesting that maintaining the most recent 32 KVs suffices to preserve optimal performance. The performance of ThinK is compared to H2O and SnapKV under the same memory consumption. The results show that H2O or SnapKV with ThinK deliver superior performance compared to H2O or SnapKV without ThinK while maintaining the same memory usage. This demonstrates that KV cache compression methods combined with query-based channel pruning can compress the KV cache more effectively and utilize memory more efficiently. Furthermore, the impact of pruning channels of the value cache is explored. The results indicate that pruning channels of the value cache can perform on par with or even better than pruning channels of the key cache alone. However, pruning the channels of the value cache over the base model Mistral 7B experiences a slight performance drop. Despite this, KV cache with additional value channel pruning can further reduce memory usage. The results are presented in various tables and figures, including Table 4, which shows the needles in a haystack test results, and Table 5, which presents the performance comparison of pruning K cache using different recent sizes. Figure 5 visualizes the performance comparisons under the same KV cache memory consumption. The paper presents a comprehensive comparison of the performance of different models in various natural language processing tasks, including single-document question answering, multi-document question answering, summarization, and few-shot learning. The models tested are H2O, SnapKV, and Mistral 7B Instruct v0.2, with different key-value cache sizes and pruning ratios. The results show that the performance of these models varies across tasks and cache sizes, with H2O and SnapKV performing better in some tasks while Mistral 7B Instruct v0.2 excels in others. The addition of ThinK pruning to these models also affects their performance, sometimes improving and sometimes degrading it. The paper also includes a needle in a haystack test to evaluate the model's ability to retrieve facts from long contexts, showing that the models perform differently in this task as well. Overall, the paper provides a detailed analysis of the strengths and weaknesses of these models in various NLP tasks and highlights the importance of considering different factors such as cache size and pruning ratio when selecting a model for a specific task. The proposed ThinK methodology targets the key-value cache in large language models, specifically focusing on the channel dimension within each head's key cache. This approach dynamically identifies unimportant channels based on data-dependent criteria, reducing the key cache size with negligible performance loss. The pruning strategy is query-dependent and optimized based on attention scores, ensuring essential information is retained for each input query. Recent studies have explored various techniques to optimize the key-value cache, including KV cache eviction and quantization. Streaming LLM, H2O, SnapKV, and FastGen have proposed different methods for KV cache eviction. while smoothQuant and QHitter have developed techniques for KV cache quantization. Pyramid KV and Pyramid Infer consider adjusting the KV cache size across different layers. Structured pruning of LLMs has traditionally focused on removing unimportant layers, heads, and hidden dimensions, but this approach often results in significant performance degradation. In contrast, ThinK preserves the original architecture of the LLM and specifically targets the channel dimension within each head's key cache. The proposed pruning strategy is query-dependent and optimized based on attention scores, ensuring essential information is retained for each input query. ThinK can be seamlessly integrated with other popular token-level KV cache quantization techniques, further enhancing inference efficiency. Extensive experiments on long bench and needle-in-a-haystack tests with two foundation models demonstrate the effectiveness and robustness of the query-dependent channel pruning method. ThinK achieves comparable or superior performance to baseline methods while reducing the key cache size by 40%. Future work will focus on strategies to increase the pruning ratio without compromising model performance and exploring pruning techniques for value caches. The proposed methodology is motivated by the observation that certain channels have significantly larger magnitudes compared to others, and the singular value analysis indicates that the key cache is inherently low-rank. ThinK can maintain superior performance over baselines with a smaller KV cache size under equivalent memory consumption conditions. The provided pages from a research paper discuss various aspects of large language models, LLMs, including their applications, challenges, and future prospects. The authors highlight the importance of efficient memory management for LLM serving, proposing a method called page detention. They also introduce a technique named SnapKV, which is an activation-aware weight quantization for on-device LLM compression and acceleration. Furthermore, the paper discusses the concept of LLM pruning, aiming to reduce the structural complexity of these models. It also mentions the introduction of LLaMA3, the most capable openly available LLM to date, and GPT-4, which is a significant advancement in the field of LLMs. Additionally, the authors explore the idea of using low-rank keys for efficient sparse attention, proposing a method called Loki. They also discuss the importance of considering energy and policy aspects in modern deep learning research. The paper also covers various other topics, such as the use of asymmetric 2-bit quantization for KV cache, the concept of LLMs with multimodal understanding, and the development of efficient streaming language models with attention sinks. It highlights the significance of efficient long-context scaling of foundation models and the potential of quantization-aware low-rank adaptation of LLMs. Overall, the paper provides a comprehensive overview of the current state and future directions of large language models, emphasizing the need for efficient, scalable, and sustainable solutions to tackle the challenges associated with these models. The paper discusses the optimization of large language models for news summarization, focusing on the importance of efficient caching mechanisms. It references Zhang et al. 2024a, who benchmarked large language models for news summarization, highlighting the need for efficient caching strategies to reduce computational costs. The authors also cite Zhang et al. 2019, who proposed HIBERT, a document-level pre-training method using hierarchical bidirectional transformers for document summarization. This work demonstrates the potential of pre-training techniques in improving the efficiency of language models. Furthermore, the paper mentions Zhang et al. 2024b, who introduced Pyramid KV, a dynamic KV cache compression method based on pyramidal information funneling. This approach aims to reduce memory usage and improve the efficiency of key-value caching in large language models. Additionally, the authors reference Zhang et al. 2024c, who developed H2O, a heavy-hitter oracle for efficient generative inference of large language models. H2O utilizes a combination of caching and sampling techniques to significantly reduce the computational cost of inference in large models. In terms of experimental details, the paper discusses two primary criteria for pruning channels in the value cache: magnitude-based pruning and query-driven pruning. The authors find that query-driven pruning is more effective than magnitude-based pruning. They define a criterion score V I to indicate the importance of each channel in the head I of the value cache, retaining only the top T channels. Overall, the paper emphasizes the importance of efficient caching mechanisms and pre-training techniques in optimizing large language models for news summarization. It highlights various approaches to reduce computational costs and improve model efficiency, including pyramid KV and H2O.